Alright students, it's time to work on pages 3 and 4 for our homework packet for Unit 1 over atoms in the periodic table. So we'll go off with a couple of Bohr models. So we'll do the first one, then we'll do the last one. So the first one says, using the Bohr models here in your periodic table, identify the following elements. Use your periodic table to find each element, write the symbol or name on the blank. So remember, to find the element, you have to figure out the number of protons. That equals the atomic number, which equals the element name. So for example, if I look at my periodic table, I'm looking for P. You see, it tells me there P equals 11. P is protons. So I look over here in my handy dandy periodic table, atomic number 11, it's right there. So this element must be Na, and Na stands for sodium. Okay, so there's that. Let's look at the last one down here, letter F. Okay, so same thing goes. What you want to do is find the number of protons. And I'm going to box that in. That way I know it's important. So 13 protons equals what element? Use my periodic table here. Well, if I remember that as I go across the periods, the numbers increase, atomic numbers increase, 11, 12, keep going, and number 13 is aluminum, Al, big A, little l. Alright, so that's how you do Bohr models. Filling in the missing information. So let's do a couple of these. So what you have to look at, notice on this one they give you absolutely no information. You have an atomic number. Well, remember, if I know the atomic number, I also know the number of protons. The atomic number also tells me the element name. Okay, so let's find it. 5. So using my periodic table, 3, 4, 5, its element B is the symbol. The name is boron. Okay, so now we have a couple more things to figure out. Well, remember, the atomic number also tells us the what? Tells us the number of protons. So over here I can jump and put 5 also. And it tells us the number of electrons because this is a neutral atom. Alright, so now let's get this other stuff figured out. So average atomic mass. That's very simple. You simply copy the number at the bottom on the periodic table. So 10.812. Molar mass is the same number. And then lastly, what you do is to get the neutrons, you're going to round this number up. So this rounds to approximately, so it'll be 10.812 rounds to approximately 11 minus the number of protons, or the atomic number. So the answer is 6. So 11, that was wrong. 11 minus 5 equals 6. So to do neutrons, remember it's just this number rounded to a whole number. So because the 8 tells the 0 to round up to 1, so that's 11 minus the atomic number equals the neutrons, and the answer would be 6 in this case. Okay? Let's look down here at number 2. Excuse me. So number 2, we have atomic mass of 118.77711. Well, that gets to be a little harder because we've got to look at this periodic table. And so remember, the atomic mass is the bottom numbers down here. Okay. And see if we can try and scan in a little bit more. Alright, and so we're looking for, remember the question we're looking for is 188.711. So as I go through, I'm looking, for the most part everything's in the right order. 118.71, and there it is. So the symbol is SN. The element name is 10. The atomic number is 50. Okay, so let's write that in. So 118.71, the atomic number was 50. Symbol was SN, and the element was 10. Remember that the atomic average mass and the molar mass are the same. Remember that the atomic number and the protons are the same. Because we're using neutral atoms, the protons and the electrons are the same. Okay? Then remember, last step. You subtract the average atomic mass, round it up. So if you round this, it would be 119 minus 50, the atomic number. So 119 minus 50 is 69. So my answer is 69. Alright? There's how you do those. Flip it over to the back on page 4. So the top part is just drawing a Bohr model. So we'll do a hard one. We'll do phosphorus. So what I need to draw a Bohr model is I need to figure out 3 things. First, I need to figure out the number of protons, number of electrons, number of neutrons. Remember that the protons and the neutrons are in the nucleus. So alright, so phosphorus, remember that the atomic number, there he is, phosphorus right there. The atomic number is the same as the number of protons, and it's also the same number as the electrons. So for phosphorus, my protons are 15, my electrons are 15. Now, to figure out the neutrons, what I have to do is I'd have to take the mass. Well, 30.974 rounds to 31. So what I did is I just did 30.974 rounds to 31. And so now what I'm going to do is go 31 minus the atomic number, which is 15, and that leaves me with 16. There are 16 neutrons. So, protons, there will be 15 protons. There will be 16 neutrons. And now I have to figure out how many shells, energy levels to draw. Well, we have to look at phosphorus. We have to look at what period is phosphorus in. Well, phosphorus is here, and it's in period 3, so it has 3 energy levels. So that's 1, 2, 3. And then the way it works is 1, 2. This is just a set of rules called the Vesper theory. What we're looking for, so that's 10. The last one should have 1, 2, 3, 4, and finish with 5. So you should have 15 electrons, so 2 plus 8 plus 5. Okay, and that's how you draw the Bohr model for phosphorus. Let's look at a couple of the ones on the bottom. Okay, so let's see, where do we want to go? If the atomic mass is 79.904, how many neutrons are present? Okay, so remember, 79.904, we have to figure out what element that is first off. So 79.904, it looks like it's bromine, so bromine's atomic number is 35. So first off, round this number, so this rounds to 80. We said bromine's atomic number was 35. So 80 minus 35 is 45. So there are 45 neutrons in bromine. Okay, go down here. A neutral element has 46 electrons. Okay. So remember, the number of electrons is equal to the number of protons, which is equal to the atomic number. So if I have 46 electrons, I need to find an element that has 46 for its atomic number. And when I go through 46, 46, 46, ta-da, it's palladium. Okay, so it's 46. It says, what element is it? Well, it's palladium, which is Pd. Is it a metal or non-metal? Well, okay, so looking at side 1 of my periodic table, is it colored with the metal area? And the answer is yes, it is a metal, because it's in the metal area on the periodic table. So it's palladium and it is a metal. Excuse me. Let's go down here at the bottom, talk about some scientists real fast, and then we're almost done with today's video. Who performed the gold foil experiment? So if you go back through your notes, there's a very, very famous experiment. He performed it in the late 1800s, almost 1900s. Actually, I'm sorry, he performed it in the 1900s. And so the guy that did that was Rutherford. He was actually an Australian physicist who came to America to study. His name was Ernest Rutherford. What did this experiment prove the existence of? Well, this experiment proved the existence of the nucleus. He also concluded that the atom is mostly made of space. Or mostly, the word should be empty space. Okay, so Rutherford did the gold foil experiment where he shot a beam of light into a gold foil piece and it dispersed, and a lot of them came back and hit back to the middle, and that was Rutherford's experiment. He discovered the nucleus with that, and the atom contains a lot of empty space. And let's do JJ. So J.J. Thomson developed the plum pudding model to describe the atom. What subatomic particle is known for identifying? Alright, so he used the plum pudding model. Thomson is credited with discovering the electron. Alright, so that's all the time we have today, ladies and gentlemen. Please continue to work on your homework. Remember that this is due when you come to class next time. And good luck.